Hello and a very good day to everyone. We are from Group 9 and today we will be presenting our assignment for ATF 31303 Application of Mathematics and Statistics in Business under the supervision of Dr. Tan Wai Hong. So, this is our group member consists of 5 members. Our presentation is organized into 5 main sections. We will begin with the introduction, followed by sampling and data selection, descriptive statistics, and inferential statistics. Finally, we will conclude our presentation with a summary with key findings. Now, let's move on to the introduction section.
First of all, I would like to express my sincere appreciation to Dr. Tan Wai Hong for your guidance, support, and valuable feedback throughout this assignment. Your encouragement and insight have played an important role in helping us complete the studies successfully. Thank you, Doctor. Okay, so my name is Aisha Shuhada binti Azrul. My number matric is A23824777 and I will be presenting the introduction of our study. Statistical data analysis is a process used to collect, organize, summarize, and interpret data in order to obtain meaningful information for decision making. It helps business and researchers identify patterns, relationships, and trends within a dataset. For this study, we analyzed a life insurance dataset consisting of 1338 observations. The dataset includes several variables, namely age, gender, BMI, number of children, smoking status, region, and insurance charges. These variables consist of both quantitative and categorical data. By applying statistical analysis to this dataset, we can better understand the factors that may influence insurance charges and gain meaningful insight that support informed decision making. Thank you.
Hi and Assalamualaikum. My name is Nurul Aya Maisara binti Yusli, matrix number 82382491, and I'm going to present about 2.0 sampling and data selection. So, the first step is to extract the last 2 digits of group members' metric numbers. Here is the size of the sample that was decided by the last 2 digits of each group member's numbers. As mentioned in the assignment guideline, the smallest and the largest number were found from the digits extract. For instance, the lowest of the obtained number was 01 and the highest of the obtained numbers was 91. Hence, 499 cases were chosen out of the first 591 cases in the data set. Step number 2 is selecting the first cases. The sample data used in this study were obtained by using a simple random sampling method. The Select Cases menu was used in IBM SPSS Statistic with the selection of random sample of cases. From the first 591 cases in the dataset, 499 cases were randomly selected as determined by the calculation of the metric numbers. This method ensures that every observation has an equal chance of being selected, thus reducing bias and producing a more representative sample for further statistic analysis. Step 3 is random sampling. A sample random sampling method was used in this study to obtain the sample data. The random sample data of cases option was checked under the Select Cases menu in IBM SPSS Statistic. Using the calculation from the metric numbers, exactly 499 cases were randomly selected from the first 591 cases in the dataset. This approach allows each observation to have an equal probability of being included in the sample, which minimizes bias and can result in a more representative sample for subsequent statistic analysis. Step 4 is deleting unselected cases. Once the random sampling was done, the dataset without the cases was deleted using the Delete Unselected Cases option in SPSS. This procedure allows the selection of the only sample to be included in the final dataset for further descriptive and inferential statistical analysis. And the last step is saving the sampling dataset. That's all from me. Thank you.
The study involved 499 insured individuals The average age of the respondent is 39 years, with ages ranging from 18 to 64 years old. The average BMI is 30.69, indicating that many respondents are in the overweight or obese category. The average annual insurance charge is 12,965 Malaysian ringgit, with a large variation among policyholders. In terms of demographic, the sample is balanced between males and females, and most respondents, about 81%, are non-smokers. The graphical analysis support the numerical findings. The age distribution is spread across different age groups, while most BMI values are concentrated between 25 and 35. Insurance charges show a positively skewed distribution, meaning most people pay moderate premiums, while a small number pay very high premiums. The pie chart also show balanced gender and regional distribution, with non-smokers forming the majority. Overall, the sample is diverse and provides a good basis for further statistical analysis.
Hi, Assalamualaikum. My name is Nur Sharifah Nazirah binti Abdullah. My number metric is 823-82453. Today I will present section 4 of my analysis, starting with section 4.1 on hypothesis testing. Hypothesis testing is a formal statistical process that I use to determine if there is enough evidence in my sample data to support a research claim. It is highly important because it provides an objective, data-driven framework for decision-making and helping me avoid biased assumptions. Based on sample dataset given, my suggestion variable for two-feature analysis is first, an independent sample t-test to compare insurance charges between smokers and non-smokers. And then second, an ANOVA test to compare charges across different regions. Moving on to section 4.2, where I performed the independent sample t-test. My goal here was to see if smoking status affect insurance charges. My null hypothesis states there is no significant difference, while my alternative hypothesis states there is a significant difference. As you can see at my SPSS output here, Levin's test gave a p-value of less than 0.001, so equal variance are not assumed. Looking at that row, the t-test shows a highly significant result with a p-value of less than 0.001. And here the group statistic tables reveals why smokers have a vastly higher mean insurance charge of 32,050 compared to non-smokers who only average 8,434. My Cohen's D effect size is negative 3.161, indicating this difference is practically very large. So in conclusion, since the p-value is less than 0.05, I reject the null hypothesis, and the data proves that there is a significant difference, meaning individuals who smoke face significantly higher insurance premiums. That's all from me. Thank you.
Now I will present our findings using the analysis of variance or one-way ANOVA. Our core objective here was to determine whether a policyholder's geographic location has an impact on their annual insurance life charges. For this test, our dependent variables is charges and our independent grouping variable is region, which consists of 4 areas. The first one is northeast, then northwest, southeast, and southwest. We established our null hypothesis stating that the population mean charges are completely equal across all 4 regions, which meaning location has no effect. Our alternative hypothesis claims that at least one region exhibits a statistically different average premium. Let's examine the generated data. As seen on this slide, we executed the ANOVA test in SPSS and extracted the structural components. To break down the table columns required by our project guidelines, first, the sum of squares measures the variation in our dataset. The between group variation is roughly 574 million, which represents differences across the regions, while the within group error variation is much higher at 71.1 billion. Next, our degrees of freedom are 3 for between groups and 495 for within group. Dividing by our sum of squares by these degrees of freedom gives us our mean squares, which represents our variances. Finally, by dividing the between groups variance by the within group variance, SPSS computed an F statistics of 1.332. This relatively small value signals that the differences between the regional averages are quite minimal compared to individual fluctuations. This brings us to our final statistical decision and business interpretation. We evaluated our test at a standard significance level of alpha equals 0.05. Looking closely at our SPSS output, the exact sig value or p-value obtained is 0.263. Because 0.263 is much greater than our 0.05 threshold, we strictly fail to reject the null hypothesis. Therefore, we conclude that there is no statistically significant difference in life insurance charges across the Northeast, Northwest, Southeast, Southwest regions. From a real-world business perspective, this indicates that the insurance provider keeps pricing structures uniform across geographic lines. Like your zip code or location is not a primary determining factor for your annual premium cost in this dataset.
My name is Asha Shuhada binti Azrul. My number metric is A23A2477 and I will be presenting the conclusion of our study. Overall, the statistical analysis was successful applied to evaluate the factors affecting life insurance charges. The finding revealed that smoking has a significant impact on insurance charges, whereas geographical region does not significantly influence insurance costs. In addition, descriptive and inferential statistical analysis provided valuable insight into customer risk profiles. These findings can help insurance companies to improve their pricing strategies and make more effective risk assessment decisions in the future. With that, I can conclude my presentation. Thank you.
Before ending this presentation, we would like to express our sincere appreciation and gratitude to Dr. Tan Wai Hong for your guidance, support, and valuable knowledge throughout this course. Your dedication and encouragement have greatly enhanced our understanding of statistical analysis and its practical application. Thank you, Dr. Tan Wai Hong.